Hello and welcome to Graphing Sine Functions. This may be a long lesson, so buckle in. All right, so let's look at the unit circle. We talk about that a sine function and cosine function have a period. That means when we talked about periodic properties, that if you take any angle, say this angle, and you rotate it one rotation, or 360 degrees, you get back to the same place. And if you do another rotation and another rotation, it goes back. And that's what we talk about a period, that it's periodic, that it is the same. And we talked about that sine and cosine have a period of 2 pi, and it gets back to the same answer. And then tangent and cotangent were pi. So what we're going to do, we're going to take this circular thing, which is circular, and we're going to try to graph it horizontally on an x, y coordinate plane. What would it look like? Would the x and y still be x and y? All right, so what we're going to do, we're going to just do the sine, and I'm taking certain angles, so our x, so this is our x and our y. So our x is going to be our input is going to be the angle. Our output is actually the ratio. So remember that sine is the y value, so we're going to just look at all the y values. Now, I didn't put all of the angles here just because there's too many of them. I only picked a few. And if we look right here, this is the first quadrant right here. So that's where I put the most. All right, so let's look at the x values. So at 0, we're going to do 0. And pi over 6 or 30 degrees, that's a half. Pi over 4 is root 2 over 2. Pi over 3 is root 3 over 2. And pi over 2 is 1. Okay, and then we're going to do 5. So I'm skipping this one and this one. You can still graph them, but just my table would be very long and it doesn't fit. So I'm just going to pick this one because half is something easy to graph. Okay, and then go pi. So I'm going to do 7 pi over 6, which is this one, which is a half. Then I'm going to jump over to 3 pi over 2 is negative 1. 11 pi over 6, which is negative half. Oop, this is also negative half. And 2 pi, we go back to 0, right? So again, there's lots of points. Remember, we're just picking some. There's still many other degrees. 10 degrees, 20 degrees, 25, 26, 29 and a half. So there's lots of little numbers in between. Now, another thing, because we're going to put it on a coordinate plane, we're going to actually need a decimal for that. That's hard to graph root 2 over 2. So take a calculator, and if you type in root 2 divided by 2, it is 0.0771. And the next one turns out to be approximately, okay, I didn't write that down, is root 3 divided by 2, 0.8660. Okay. So we're going to use this information. I'm going to change it to the next slide, and we're going to use these same numbers, and we're going to plot them. All right, so these are the numbers that we've done, that was in the previous slide. I've just made everything decimal, so it's a little bit easier to graph. Now, because of our x and our y, remember this is our input, this is our output. So our x is actually the angle, right? This is the angle in radians. So this is our x. So our x values, as you can see, it's in radians. So that's different than other graphs that we've done. Usually it's just 1, -1, 2, right? -3, -2, -1, 0, 1, 2, 3, 4, 5. These are not. But what about our y? Now, our y-axis, it's blank. So you actually have to label it. So please make sure, because it'll change often. So for this one, I'm going to put the 1 right here. Therefore, this is going to be -1. And you can see that the numbers here in sine, they don't go more than 1. And they don't get smaller than -1. I don't know if you've ever noticed that when we did things. Sine always stayed between -1 and 1. All right, so let's graph. So I am going to start here at 0. So this is 0. This is graph in orange. And this is going to be our parent graph. That's 0, 0. A pi over 6. And you're like, Miss Mendoza, I don't even see pi over 6. That's right. But you can see pi over 6 is before pi over 4. So that means it's right about here, right? Because pi over 6 is 30 degrees. And this is 45. Okay, so, and it's half. So half would be about here. Okay. And then pi over 4 is 0.7, so that's about 3/4 of a way. 60 degrees would be about here, and that's going to be a little bit higher. And then at pi over 2 or 90, it's going to be 1. So what happens when we go down this way to the right, if you remember our unit circle, and I didn't put this on the table, these numbers, right, they go half, √2, 3 going this way. When you're coming down this way, it's the same numbers, but going backwards. √3 over 2, √2 over 2, and half. See, these goes up, and it's the same numbers here, but going down. So what's going to happen to our graph, even though I didn't put them on the table, we're going to go down this way. Oops, right underneath. This is going to be 0.707. This one's going to be a half. That's 5 pi over 6, which is close to pi, and then here. Okay. So it has a nice little curve to it. So going down, now we're going into negative. So remember, in our unit circle, from here to here, this is our first quadrant. From here to here, that's our second quadrant, which is both positive. And then for here, it's going to be negative, so it's going to be under the x-axis. So when you graph that, 7 pi over 6 is -1/2. So it's about here. And the next one is 3 pi over 2, which is 1. And you're like, Miss Mendoza, what happened to all those numbers before? Remember, it's going to come back to be about the same. It's about here, and it's, oops, about here, and then here. Okay. And then coming down, half is going to, oh, that was the wrong point. Sorry, that wasn't half. No, it's up here. Oh, it was half. Sorry. Half is about here, and 2 pi is 0. Okay. So this one's about there. So what happens, it's going to be the same number. It's going to come up like this. It's going to curve, and it's going to come up like that. And it starts to plateau out. Oops. Not a perfect way. And then starts to plateau off this way. Okay. And you're like, well, what about the other side? Well, remember, it still has that cyclic or cycle. So if we started over here, right, at this number, it would be up here. And here it would be, oh my gosh, I'm so sorry. It's me not seeing upside down. My bad. Sorry, my 1 is here. No, too high. So it would have looked like this. My bad. I just noticed that. So sorry, so sorry. There you go. It looks funny upside down. Okay, but there you are. So they're saying these points right here, I call them anchor points. The cycle has to be the same because at negative 2 pi, right, it'll come up, that's through the first quadrant, because remember, it goes around in a circle, and we're just opening it up to be horizontal. And there you go. It has this beautiful cyclic cycle. All right. So let's talk about some things. Domain. So it's going to, even though it goes down like this, it's going to still have that cycle. It's going to go down and then it's going to go back up. It's here. It's not going to turn suddenly into a straight line. It's not. It's going to go like that forever, up and down and up and down, like a nice wave. So your domain is all real numbers. The range, those are your y values, and you can see it's going from -1 to 1. Noted that it's brackets because it does equal to -1 and 1. All right, so amplitude. Now, if you're looking at our notes, and if you printed them out and they're on Canvas, it says that the amplitude is a distance from the x-axis. So what it's saying here, here's my x-axis. Right, there it goes. What is the highest point? What's the distance of that to the highest point or to the lowest point? So we're looking here, right? We said that the highest would be 1. So the distance here is 1, which is still the same distance as here. So we're talking about the absolute value. We mean distance, not positive or negative. I'm going to say this. Amplitude is always positive. I'm going to say it again. Amplitude, always positive. So these are going to be new terms for you that we have not had for any functions before. All right, and so that's amplitude. So how high is it? It is 1. Right? The period. The period is the length of one cycle before it repeats. So my cycle, let's get a different color, is from here, right? All the way here. That's one cycle. And how far is that? That's from 0 to 2 pi, so that is 2 pi. So my period is 2 pi. So do you see this is the other cycle here? Right? How far is that? That's from -2 pi to 0, which is still the length of 2 pi. All right. I'm going to do the x-intercepts first. The x-intercept, there's only one of them. I'm sorry, I'm going to do the y-intercept first. And that is going to be 0, 0. Because the x-intercept is a little bit more complicated. Okay. Because, let's look at that. It's here, it's here, it's here, it's here, it's here. It's going to keep going. It's going to keep going, and so let's look at it. It's -2 pi, -pi, 0 pi, 2 pi. So after 2 pi, what do you think it's going to be? That's right, 3 pi, and then 4 pi, and 5 pi, and 6 pi. That means it's going to be every pi. How do I write that? All right, so you're going to have to write it algebraically, and this is going to be a little different. So we write it this way. So we write k times pi 0. And you're like, what? Wait for it. So now we have to say what k is. K is the element of integers. Now we generally often don't use the different number sets, and you learn them in Algebra 2 maybe once, but that means integers. So it's saying this. Integers are positive and negative numbers, whole numbers, no decimals, no fractions. So you're saying k can be -2, -1, 0, 1, 2, 3, 4, 5. So it'll get you that repeating that we're looking for. So we're saying, oh, that's -2 times pi. That's -1 times pi. That's 0 times pi. That's 1 times pi, 2 times pi, and so on and so forth. We will see k often when we do trig functions. That idea will come back, right? Now, sine graphs are called sinusoidal, that they have this nice period repetition pattern that is continuous and beautifully smooth. Sinusoidal. And this function and cosine functions are important because sound waves has this shape, right? And people play around with sound. They can see the different amplitudes and if it's a big number or small number, what happened to that sound. All right, so there's some other things we need to discuss before we move on. I know it's a lot, like I said, because this is new. It's a lot of new terminology. Anchor points. A sine function has 5 major anchor points. Now, usually we graph in the first cycle, but I just anchored here, but that's okay. Maybe we'll do it in a different color here. Anchor her. 1, 2, 3, 4, 5. And these points come from the x and y axis in the unit circle. So for, like, this is the parent function. So for sine, this is important because this is how I will graph things every time. The first and the last point will always be defined by the period. So if we start, so it starts at 0 and will end at 2 pi. And it will always be at 0 unless we shift, and we will, but this is just for the parent graph. The middle point is halfway between that. So if your period is 2 pi, the halfway would be pi. If your period was 4 pi, the halfway mark would be 2 pi. Now, half a pi is half again. And that's where the other point will be, and it will be at 1. The next and last anchor point is halfway between pi and 2 pi, and that will be at -1, right? Okay, so 5 anchor points, dividing it into 4 parts. Do we know why there's 4 parts? That's right, they each represent the quadrants. First quadrant, second quadrant, third quadrant, fourth quadrant. Okay. Parent graph, and we're going to be graphing the parent graph quite a bit. Let's go graph. Oh, that's before we graph. Let's talk about the function. So when you look at the function, our basic function was here, sine theta. Now this is with theta. Sometimes I write it as theta, and sometimes I write it as x. It's the same thing, just different variables. And this is a basic one that we're going to deal with today. So the number in front stands for the amplitude, and we talked about that. The distance from the x-axis to the highest or lowest point of the graph. Distance-wise, which it would always be positive. H, just like any other graph function that we've graphed, represents h. That is going to be our shifting to the left and right. So these are called horizontal shifts. Horizontal shifts. And K is up and down, right? It's one at the end. And we call them vertical shifts. Now the textbook will use different variables, and so will online, on the web. So they may use Greek letters instead. Okay, so now let's practice graphing. All right, so here's a graph. We have sine x, and you can see that it is +2. So what is the +2 on the outside? Not inside with the x, on the outside. That means it's going to move up. You can see we're going to look for the amplitude, the horizontal shift, and the vertical shift. So the amplitude goes in front. And since there's no number in front here, that is assumed to be 1. So the amplitude's 1. The horizontal shift is 0. And my vertical shift is up 2. All right. So because of this, we haven't changed the period. All of these will be period 2, or 2 pi. And so we're going to graph the parent function first. Okay, so let's practice how we do the parent function. So first of all, let me find, I'm going to put 1 here. And you're like, why are you going to put your 1 here this time? Because I have to move it up 2. So this is going to be 2 and 3 and 4. So it'll give me space to move. That's why we don't number the y-axis. Don't forget you need to do that. Okay, parent function of sine. Start at 0, remember? And the period is going to go to 2 pi. Cut it in half. That's at pi, and that's going to be 0. I'm going to cut that in half is here. It's going to be 1, and then down 1. Okay? So you're going to do the same thing on the left. Negative 2 pi, cut in half here. So we have 3 x-intercepts, right? Halfway between, it's going to go up 1. Halfway between, down 1. We have this nice, I practiced nice curve. I don't want any pointy, they're not V's, curved, smooth. All right. And then it's saying, okay, everything moves up 2. Yeah. So my new x-axis is really going to go through here. So I'm just moving all my points 2 up. So this is here. Right? So 2 pi is over here, remember? It's going to be on that new x-axis. Halfway between, there it goes. Up here. So it's also 1, 2, like 1, 2. See? It's down here, 1, 2. So it's 2 up this way or 1 from your new x-axis. It's not a real x-axis, but it's kind of how we graph that. You just graph here, here, up 1, down 1. So you can see that it's running parallel to our original labelment. That's f of x. Right? So that means I shifted all the points 2 up. All right, let's look at this one, g of x. Now we can see that pi over 4 is inside. So it's inside in the parentheses with the argument. My amplitude, there's no number in front over here, so that's still a 1. My horizontal shift, now remember, is going to be opposite. So that's pi over 4. And my vertical shift, that's going to be none. It's none because there's no number out here, right? That's my vertical shift. Okay. So I'm going to put 1 here. I guess I'm going to put it in the same place so not to confuse us. All right. Parent graph. Okay. 0, 2 pi, 0, pi. Pi over 2, 1. I always start at the 1 on the right. I don't know why I always do the positive, but you don't have to. Yes, do the parent graph. Yes, smooth. If you give me a sine function that looks like that, it looks like pumpkin teeth when you're carved. No, I'm going to mark that wrong. They're not mountains, peaks. That's what, no, it looks like teeth, right? You want it more smooth. Hills, beautiful rolling hills. All right, so now it's saying a horizontal shift pi over 4. So you're moving everything to the right, right? This is to the right. So you're taking this point here and you're moving it one to the right. You're moving them one to the right because pi over 4, right? Pi over 4, pi over 4. This one's over here, can't see it. Pi over 4, moving, right? Yeah. So now, but it still has that. Now I'm going to connect them. It still has a nice, smooth, beautiful curve. And for your graphs, I like 2 periods. 2 cycles. Okay. All right. Amplitude change. So if we look, you can see that it says 3 in front. That tells me it's amplitude of 3. There's nothing over here with the X, so there's no horizontal shift, there's no vertical shift. Okay, so what does the amplitude do? It stretches it, so it stretches it vertically in both directions. So it stretches. You can go that way. And you're like, what? Because of the hills and the valleys that it has. I'll show you in a moment. Parent graph. Oh, and I'm going to do this as 1. Okay, I'm going to start here just to change it up. I think graphine's so relaxing. There, nice, smooth. All right. Okay, so the amplitude, what it does, we have our nice anchor points on the x-axis. Those are not going to change when you change the amplitude. These stay, they anchor it. But you're taking all the other points and you're multiplying it by 3. So the reason why these anchor points at the x-intercept stay, because 0 times 3 is just 0. But 1 times 3, oh, that's going to be 3. And negative 1 times 3, ooh, that moves down here. And so this one's going to move down here. And they're being multiplied by 3. So do you see it stretches up from here to here? But even here it stretches downwards. So that's what I mean. It goes in both directions. But the x-intercepts, they stay. They're anchored. So even the half is being multiplied, right? So here, half is about here. That would be 1.5. But we're not going to do all the extra points. We're just going to do, we know what it generally looks like. So we're going to draw this nice, beautifully smooth, and then come back down. And don't worry if you don't get the hang of it yet, and it's not perfectly curvy, it's fine. I just don't want points. So just try to do the best you can. And even look here, not so good down there. But that's fine. Nice and smooth, all connected. So that's what the amplitude, that number in front, it changes that. It stretches it. All right, next one. Ooh, a negative in front. We wonder what that's going to do. All right, so we can relate them to all our other types of functions of parabola. So what does that do? That's right, it flips it over the x-axis. So it reflects over x-axis. And the reason why we're doing the parent graph function for all of them, so you can see how it compares to the original and what's really happening. So the amplitude, since there's no 1, it's 1. You're going to say it's negative. No. Negative tells me which way it's going, but remember, amplitude is distance. This is going to be 0 and 0. So amplitude, always positive. I'm going to say it again. Amplitude, always positive. Yes, I'm doing a parent graph. Yes, you have to. All right. Parent graph. Okay. Not the best. There it goes. All right, I'm going to do this one in block. So it reflects it over the x-axis. So 0 over 0, And then it doesn't really flip. But instead of that one here, it's going to be here. This is going to stay. Not -1, it's going to flip on the other side. The 0 is going to stay. This -1 is going to go up. 0 is going to stay. This one's going to come down. It's going to stay. So what happens, instead of going up, they now go in the opposite direction, which makes sense because that's what negatives really do, opposite. And I'm going to label it this, so when you look at it later, you'll know which one's which. I don't think I did that on the other ones. This one I think is a little bit more obvious. And I'm going to say that it is helpful for different colors, especially for these. Okay. And there you go. Isn't that beautiful? So pretty. Okay. Now, these are all separate ideas. Just one transformation is happening, but what if we put them together? What starts to happen? All right. So let's look at this. Okay. So I have an amplitude of, remember amplitude is in front of 1. Horizontal shift. Okay. That's pi/2 negative. So that means left. -1. Which means down. Okay. Parent function as always. And because I'm shifting down. All right. Here we go. Okay. All right. So what is happening? So we're not stretching it. Our amplitude is going to be 1, so that part's not going to change. So the -1 tells me I'm going to move everything down 1. Okay. And then the horizontal shift means I'm moving everything to the left pi/2. So pi/2, if I'm looking over here, here's my 0, here's pi/2. So that's 2 spaces, right? So I'm moving 2 over to the left and down 1. Okay, so 2 over and down 1. So over here, it's 2 over and down 1. This one's 2 over and down 1. This one is 2 over and down 1, right? So this way, I really should have started on that side. It's okay. So 2 over and 1 down. 2 over, 1 down. 2 over, 1 down. 2 over, 1 down. Okay. And so we are going to go here. Now you may have different strategies and different ways that you do that. That's fine. Right? Beautiful. This is K of X. So you can see that we dropped down, right? We had the nice drop and we moved that way. All right, let's look at this one. Okay, so what do we have now? Here I have, all right, I have an amplitude of 1/2. Positive and negative tell me reflect. So it's going to flip it over the x-axis. Okay. There's nothing here, so that's going to be 0 and 0. Okay. Paragraph. Now, because it's 1/2, and you can really, if you want to put 1/2 here, that's fine. It's really up to you, or you can put 1/2 here, or wherever you want, really. Now let's put it there. Sure, why not? So the highest point will be at 1/2, the lowest point will be at -1/2. So my parent graph at 1, because now I stretched it out. And because this is a really new graph for many of you, yes, I do want you to do the parent graph. It'll help you know the shape of this, again, because it's new. Okay, so we're flipping down and we're going half. So I'm just going to show you very lightly. So I know I can't pass that, right? Here, so it'll be between there. Okay, and we're going in the opposite direction. So instead of, here we'll start here. Instead of going up, we have to go down. But we anchored. Instead of down, we go up. It switches places. So we're going to do that here too. And there. Okay. Oh, you know what? And we haven't done domain and range. We should probably do domain range just for this one. Domain, overall numbers. Range. Okay. Because we changed it, it's now going from negative half to half. Okay. And then this is d of x. Lovely. So cool. All right, practice on your own. Now, if you're looking at this, there's a bunch of things going on. I won't tell you what they are. Just take each one at a time. And if you've printed out or looked at the notes, I've actually put the graph there for you to graph that. All right, good luck. Thanks for watching. Bye.